way of expressing the concentration of a solution is the molarity. Now, the molarity term is also related with the number of moles as it is significant as it is we're coming to know from the name of the it molarity related to the mole. Now, what is it? It is the number of moles of solute dissolved per liter of solution, right? So what is the formula of it? That is molarity equals to number of moles of solute. Now number of mole of solute is generally expressed by small n. Either we can write down here solute or you can write down NB also, right? So number of mole of solute divided by volume of solution. Now if you will write here in liters, right, it will be till here only. But when you are expressing the volume in term of milliliter, right, that is volume of solution in ml, milliliter, it will be multiplied by 1000, right? So what is the molarity? Molarity is the number of moles. Here the amount of solute is measured in term of number of moles. So number of moles, how much number of moles are dissolved per liter of solution, right? The solution quantity is how much? It is 1 liter or it will be 1000 ml. Now here you can see now what is going to be the unit of it, unit of the molarity. So here it is the number of moles, we will write it as mole, right? Now volume, if expressed in term of liter, it will be mole per liter or mole per milliliter, or we can write down simply capital M. Now here if I write it in this way, 0.25 m of sodium carbonate solution. Now student, what do you mean by this 0.25 m? It means that 0.25 moles of sodium carbonate dissolved in 1 liter of solution, right, or 1000 ml of solution. In the same way, what is the meaning of 1 m of HCl? It will mean 1 mole of HCl dissolved in 1 liter of solution. Now how we can obtain 1 mole of HCl? Just if we are given the given mass of HCl, we will just get it divided by its molar mass. Now students, the molarity, it depends upon the temperature, right? So here, this is important one. Molarity depends upon temperature. Can you just find the relation that how it is going to depend upon the temperature and why it is depending on temperature? You can just get your answer from the formula itself, that why the temperature is going to affect the molarity. Now in the formula we have got three terms, molarity, number of moles and the volume solution. Now which is temperature dependent? Yes, it is the volume of solution. So molarity depends upon temperature because with change in temperature, volume of solution gets affected and hence molarity changes, right? This is about the molarity term of expression of the concentration. Now after molarity, we have the next term of expression, that is the molality, right? Here we have got molality, right? Now it is the number of moles of solute dissolved per kg of solvent. You can easily see the difference, that it is the per kg, that is it is the mass of the solvent, right? So molality. Now here the molality denoted by small m. Molality, it is the number of moles of solute upon weight of solvent. If it is in kg, it is mass of solvent. If it is in kg, we will not get it multiplied by 1000, but if it is number of moles of solute upon mass of solvent in grams, right? We will get it multiplied by 1000, right? So it is mass of solvent in grams, then we will multiply it with 1000. Now what is going to be the unit of it? It will be mole. In denominator we have mole, and mass of solvent in kg. So it will be either per kg, or it will be mole per gram, or it is denoted by small m, right? So if it is written same 0.25 small m of sodium carbonate solution, what does it mean? It means that 0.25 moles of sodium carbonate is dissolved in 1000 gram of solution or 1 kg of solution, right? Now here, is this molality dependent on the temperature? Molality depends on temperature, right? Again you will see the formula. The answer lies here only, that you can see the molality depends upon the number of moles factor, and there is a mass of solvent in kg, right? So if does any one of these is affected with the temperature? No, right? So molality dependence on temperature, so it is independent of temperature factor, because mass will remain constant with the change in temperature. Now the next expression of concentration is the normality, right? It is the number of gram equivalent. It is the number of gram equivalent dissolved per liter of solution, right? So here the normality, it is expressed as capital N. Here we have to know about the number of gram equivalent of what? Of solute, right? Divided by, it is volume of solution in liter. So it is the number of gram equivalent of solute dissolved per liter of solution. In the same way, when expressing it in term of milliliter. So number of gram, I'm writing gram in GM, gram equivalent of solute divided by volume of solution in ml. If it is in ml, we'll get it multiplied by 1000. So students, here to find out the normality, we need the number of gram equivalent. Now, how we are going to calculate the number of gram equivalent, right? To calculate the number of gram equivalent, the mass of the solute will be given to us, and second is we know about it molecular mass or the molar mass, right? So number of gram equivalent of solute is equal to given mass of solute divided by equivalent mass of solute. Now student, you know about the molar mass. Now how we are going to get the equivalent mass of a solute, right? To get the number of gram equivalent of solute, we need the equivalent mass. Given mass, it will be given to us, but equivalent mass we have to calculate. Now if it is an acid, right? Let it be H2SO4. I am taking H2SO4 here, right? To know the number of gram equivalent, or sorry, equivalent mass. To get the equivalent mass of sulfuric acid, we need here the molar mass of it upon its basicity. Now what is the basicity here? For the acid, it is the number of replaceable hydrogen ion. So you can find out easily the molar mass of it. It is 1 into 2, 32 plus 16 into 4 divided by 2. So it will come 2 and 64. How much we are getting? 34 plus 64, that is 98 divided by 2. So we are getting 49. So 49 will be the equivalent mass of sulfuric acid. So in case of acid, the equivalent mass will be known by dividing the molar mass of that acid upon the basicity, that is here number of replaceable hydrogen ion, right? In case of sulfuric acid, it is how much? It is 2. Now in case of a base, now let it be NaOH. Now its equivalent mass, right, will be the molar mass upon acidity, that is the number of replaceable OH negative. It is number of replaceable OH negative. So molar mass Na is 23, oxygen is 16 plus 1 divided by 1. So here it is how much coming? So it is 23. So it is getting 39 plus 1, right? It is coming 40. So 40 will be the equivalent mass. Now to find out the number of gram equivalent of acid or a base, right, it will be given mass, will be given in the numerical or a question, and to get the equivalent mass we will use this formulas. Now these are the different ways of expressing the concentration of the solution.